Hi guys, in this video we'll know the types of matrices, and here I have listed the most important matrices or most important special matrices, which are square, rectangular, row, column, identity, zero, diagonal, scalar, lower triangle, upper triangle, transpose, symmetric, and skew symmetric matrix. Before to introduce this one, we will know how to compute the negative of matrix. First of these, and of course here we will list them as this order. First one, square matrix. From the name square matrix, as we know, the square is each opposite side are equal. This is the same thing. So here the number of rows equal number of column. Here I mean here of this one, number of this hash here, number of, and the same as this one. So here number of rows equal to number of column for square matrix. For example, the simple one is 1 by 1 matrix. For example, here -1, here 1 by 1 matrix, this one. Another example, 5 2 3 -1, this 2 by 2 matrix, and so on. We can put here 3 by 3 matrix. This 3 by 3 matrix, I will explain more what is this one and what is this one. Here, this one, number of rows, 1, 2, and here in purple, this one, number of columns. The same thing as this one. And of course here you can put any size as you wish. For example, 100 by 100 matrix, which is square matrix. The second one is rectangular. We will write it here. Here, rectangular matrix, opposite of this one, number of rows not equal number, number of column. For example, this 2 by 3 matrix, 2 rows and 3 column, which is rectangular matrix. Another example, this one 4 by 2, and so on. You can write any size you want. Of course, the number of rows not equal to the number of column, then it will be rectangular matrix. The third one is row matrix. Row matrix or row vector, and from here the name row vector, it's mean only one row. So example of this one, it's very easy, which is like this, 1 or -1, 2. It has one row, just one row, 1 by 2, this, because one row and 2 column. And here this one, 1 by 3, and so on, because here 3 column. And as you noticed here 1, here 1, so it has only one row. So this is the row matrix. Now we will talk about column matrix. Column matrix or column vector, for example, it has only one column, 3 2, This has only one column. So this one, 2 rows and 1 column. So 2 by 1. Another example. This one, 3 by 1 matrix, and so on. As you can see here, it has only one column. This one has only one column, so this is column vector, example for column vector. Now we will know about identity matrix. Identity matrix, for example, this 1 by 1 matrix, or 2 by 2 matrix, 1 0 0 1. As you can see here on the main diagonal is ones. Here's this called main diagonal. This is main diagonal here, 1 1. The entries 1 1 and the entries 2 2. Of course, this one 2 by 2 matrix. And here an identity matrix has ones on the main diagonals and everywhere else are zeros. So here zeros. Let's introduce 3 by 3 matrix. This is 3 by 3 matrix. As you can see here on the main diagonal ones and everywhere else are zeros. And so on. You can put 10 by 10 matrix, which has the same thing on the main diagonal ones and everywhere else are zeros. Now we will introduce the zero matrix. Here zero matrix, or they called it null matrix, which is very simple. 0 here, only 0. This is 1 by 1 matrix. It's opposite of this one here, only 1, and here only 0. Or you can write 0 0 0 0, this 2 by 2 matrix, and they called it null matrix or zero matrix. You can put 2 by 3, 3 by 2, 3 by 3, or any size you wish. Now we will talk about diagonal matrix. Diagonal matrix, it's similar to identity matrix, but in diagonal matrix has numbers here not equal to 0. So for example here, 2 0 0 minus 1. You can see here on the main diagonal numbers and everywhere else are 0. So a diagonal matrix has 0 everywhere except the main diagonal. This 2 by 2 matrix. Let's put example for 3 by 3 matrix. As you can see here on the main diagonal here has number, everywhere else are 0. This is 3 by 3 matrix. And so on. Now we will introduce the scalar matrix. Example of scalar matrix. Scalar matrix has similar to identity matrix, but here in scalar matrix has numbers on the main diagonal and they are the same. So a scalar matrix has all main diagonal entries the same with 0 everywhere else. So here 0 and here the same numbers. This is 2 by 2 matrix. Another example, 3 0 0 3. This is a scalar matrix because they have the same number and everywhere else are 0. This is the same 2 by 2 matrix. For 3 by 3 matrix, we will put example here. 3 by 3 matrix. So the main diagonal here has the same number, 8 8 8. So this is scalar matrix, and so on. Now we'll introduce triangular matrix. Here we have triangular matrix, and here triangular matrix has either lower triangular matrix or upper triangular matrix. You can say this one is triangular matrix, but if you want to be more specific, you can say lower triangular matrix or upper triangular matrix. What is lower triangular matrix? For example, let's look like this. For example, here 5 0 3 minus 2. This is 2 by 2 lower triangular. Why it's triangular matrix? Because here we have right triangle. You can see here we have right triangle, and here if this shape like this, then it is lower triangular matrix. Another example for 3 by 3 matrix. This is 3 by 3 matrix, and as you can see here, right triangle look like this here, and so on. This is lower triangular matrix. As you can see here, the right angle here, the right angle here. For upper triangular matrix, this angle, it's opposite. It will be here. For example, here, it's look like this. 2, 5, 0, minus 5, for example. See, right triangle look like this. And here, the right angle here. So that's why this called upper triangular matrix. Another example, 3 by 3 matrix. The right triangle here, it has here 90 degree, and so on. Lower triangular matrix is when all entries above the main diagonal 0, above the main diagonal 0, where upper triangular matrix is when the all entries below the main diagonal is 0. So here, below the main diagonal are zeros. Now we will introduce for you transpose of matrix. Transpose of matrix is very simple. It's only you have to swap the rows and column. So rows become columns and columns become rows. It's very simple here. For example, we have A equal. So here the A transpose, the symbol of transpose here, it's look like this. So A transpose, this is transpose here, T. equal, we have to swap the rows with column. So here, this row, it will become column. So 5, 2, I swap this one to here. The same thing here, this row, it will become column. So -3, 4. This row, it become column. So 0, 1. Another example, B equal, I'll put simple example here, 5 to 9. This 1 by 3, because 1 row by 3 column. B transpose, it will be, we have to swap this row to become column, so it will be like this, 5 to 9. So now we have 3 by 1. The same here, we have 3 rows and 2 column, 3 rows, 2 column. Then after the transpose, this one transform to 2 by 3. So A, 3 by 2, transform to this matrix, which is 2 by 3. So A transpose 2 by 3. Now we will talk about the negative of matrix. Here it's very simple, the negative of matrix. For example, if we have, let's say, A equal 5 to 0 minus 3, then the negative of A, the negative of matrix A equal, we have only to multiply 5, multiply by -1, which is minus 5, multiply by -1, which is minus 2. This one, it will remain the same. -1 multiplied by -3, it will be 3. Now we will know about symmetric matrix. Here we have symmetric matrix, which is A equal A transpose. So if this condition satisfy, then we can say this is symmetric matrix. So a matrix whose transpose is the same as the original matrix. For example, A, this is given matrix. So if we want to test if this symmetric or not, we have to take the transpose. So let's write it in another color. So then A transpose equal, so this one, it will become column 1, 2, 3. This row will become the column 2 minus 5 minus 1. This row, the third row, it will be the third column. So 3, -1, 6. Let's compare these two. So 1, 1, 2, 2, 3, 3, 2, 2, -5, -5, -1, -1, 3, 3, -1, -1, 6, 6. Since these matrices are equal, then, or since A equal A transpose, then A is symmetric matrix. Now we will introduce for you the skew symmetric matrix. Here we have skew symmetric matrix. It is skew symmetric matrix if satisfy this condition A transpose equal to the negative of A. This means a matrix whose transpose is equal to the negative of the original matrix. Example for this one, let's say we have this A. To test if this skew symmetric or not, we have to compute A transpose and the negative of A. So here we will compute this one first, A transpose. This row to become column 0, 6, -3, and this row to become column -6, 0, -1. The last row, it will become the last column here, 3, 1, 0. Now we will compute the negative of A. The negative of A, it's very simple. We have to compute the negative of this one. So it's only multiplied by -1 for the whole matrix. So here 0, -6, 3, 6, 0, 1, -3, -1, 0. Now we have to compare this one with this one. So 0, 0, -6, -6, 3, 3, 6, 6, 0, 0, 1, 1, -3, -3, -1, -1, 0, 0. So since this matrix equal to this matrix, then it is skew symmetric matrix. Since A transpose equal negative of A, then this A is skew symmetric matrix. That's it. So we have listed the most important matrices in linear algebra, and it's very important to distinguish between them. If you have any question, feel free to put comment on this video. See you in the next video.